Hi there! This video series is to display my problem-solving and learning abilities. I hope to show that I can solve any programming problem, regardless of whether I already have expertise in the language at hand. I hope this helps others in my field to learn not just how to solve a particular problem, but how to teach themselves a solution to an unfamiliar problem. For now, I am learning Python. I have no professional experience or formal training in the language, and have only been learning it since mid-January. While I'm picking up fairly quickly, I cannot claim any real expertise. Today, I am going to show my approach to solving the sixth Project Euler problem. I haven't looked at this one before, so I'll be starting completely fresh and talking through my thought process. I will link to both Project Euler and my repository in the description. Let's dive in. Problem 6 is sum square difference. So it says the sum of the squares of the first 10 natural numbers is all of that, and then the square of the sum of the first 10 numbers is this. Hence, the difference between the sum of the squares of the first 10 natural numbers and the square of the sum is second number minus first number, 2640. Find the difference between the sum of the squares of the first 100 natural numbers and the square of the sum. So, copy this part. So, sum of squares is we square the number and then add it. Square of sum is we add all the numbers and then square them. Okay. Gonna try to keep that one in mind. So we gotta open our new little problem 6.py. Have a little comment here. Okay, so the first approach that comes to mind is a very simple then just go through all 100 numbers and just do the math. So for that, I would want to have a sum equals 0 and a sum squares also equals 0, and then just for, I'm going to say n in range 1, 101, so that we are inclusive of the number 100. Sum plus equals n, sum squares plus equals n times 2. And that might be unnecessary parentheses, but I'm a little bit paranoid. And then squared sum equals sum times sum. Actually, that's not n times 2, that's n times n. And then print, let's see, in our example, which one's bigger? So the square of the sum is the larger number. That is likely going to hold true, I'm guessing. I don't actually know for sure. But it seems reasonable that if this number was a lot smaller than this one, in the up to 10 example, then the up to 100, it's going to hold that pattern. So square sum minus sum of squares. And actually, just for the sake of being able to see a little bit more data, let's do square of sums equals squared sum, and oh goodness, sum of squares sum squares. Alright, and let's see how quickly we go through this here. Python Okay, so we got a square of sums, and this is our number. Let's go ahead and check whether that is correct according to Project Euler. Okay, so that one was actually relatively quick, and as you can see, like, as you noticed, it also ran very, very quickly. Again, one of Project Euler's suggestions is that every program you create to solve the problem should run in under a minute, and we definitely hit that in this case. Relatively soon, I should start adding the difference between start and end times just to have that absolutely confirmed. But I'm waiting to see when I run into that problem before I solve for it. So yeah, I would say there's almost certainly some math that can be done to make this somewhat more efficient, and in some languages that would certainly matter. But for Python, it clearly does not. So yeah, let's go ahead and call it a day. I'll see you in the next one.